Hello everyone. In this video, we are going to discuss about the Cat 1, uh, the Cat 1 which will be held tomorrow. Uh, Here in this video, we are going to discuss about that Cat 1 uh, from i- from the yesterday revision class Zoom lecture from our lecturer Mr. Uday Kumar sir. Uh, this the summary of the yesterday lecture of Mr. Uday Kumar sir. Okay, let's discuss about now we are going to discuss about DMB 3301 Cat 1 Cat 1 about Cat 1. Okay, Cat 1. Here we need most sir said that we need uh, some A level some equations which were studied in A level. For example, we studied in A level advanced level that PV is equal to NRD. PV is equal to NRD. If n is constant and r is constant, then PV we already studied this. Okay, well, one equation is PV is equal to NRD. Another equation is if n is constant and r is always constant, therefore PV by D. We already studied in advanced level. PV by D is equal to constant. We already discussed in studied in constant, studied in advanced level. Sir said that we need some equations like this. We studied in chemistry and physics also. It will be helpful to our tomorrow exam. Okay. Then he said that mostly the question will be focused on first non-flow equation, non-flow equation, non-flow equation. Wait a minute. We can say that non-flow energy equation. Okay, non-flow non-flow energy equation. We say that we have to find some questions from non-flow energy equation. We need the basic theory of the non-flow energy equation. Energy equation. We can discuss in stupid class about non-flow equation. Don't worry. I just memorize everything. Okay. It's wait. Wait a minute. Okay. Sorry for the late. Okay. We need a lot of page to discuss. Yeah, sorry. Okay. Now we already discussed that we need some equation like PV is equal to NRD. PV by D is equal to constant. Okay. It's very simple. We already discussed it in studied in year advanced level. Now, first we discuss about we need non-flow. We already discussed that we need exam paper will focus. Sometimes we need we they will ask in non-flow energy equation. Non-flow energy equation we already discussed. Then second one, the question may be ca- ca- uh, they go they will ask from steady flow. Okay, steady flow steady flow equation, steady flow energy equation, energy equation. We can discuss about in the question. Okay, don't worry about. I just summarize the next yesterday lecture. First, the question may be they will ask from non-flow equation. Second one, uh, steady flow equation. Third, continuity equation. Continuity equation. Okay, continuity equation. uh, then they say that we may get they will ask from some they said that if we study from if we study steam steam power cycle share in yesterday lecture share talked about share told discussed about steam a little bit about a steam power cycle. Steam power cycle, turbine cycle, steam power cycle, turbine turbine cycle. Okay. Uh, Therefore, mostly the question will be come from non-flow equation, steady flow equation, continuity equation, steam power cycles, turbine cycles. The question, how many questions will they ask? Only they say that they will only ask it three questions. Total time 75 minutes. The exam is only for 75 minutes. No, therefore they will ask only three questions. Okay. Here say that don't need we don't need steam table. Okay. Uh, in before last year in previous years we wanted steam table to do some questions steam table, but in this year we don't want the steam table because they will give the required values for why we need the steam table because we need some required values to do calculation. They say that they will give all the required values. Therefore we don't need the steam table, and we don't need to find it in steam table. Therefore we can minimize our time. Therefore say that it's very easy to us. Therefore we don't need to worry about steam table. They will give all the required values. Therefore uh, we don't need. Okay. Because say that really the steam in practical life steam table steam, if you find the steam table, it will be in 10 pages. Okay, 10 pages. It will be in 10 pages. Okay. Yeah, I was just say that it will if they give the cost of if they give 10 pages, if they allocate 10 pages for steam table, the cost of the paper will be increased. Therefore, they will not to reduce the cost of the paper exam paper. They will not give the steam table. We don't need the steam table because they will they will the required values of the uh, steam table. Okay. Then not only we can discuss about it next. This is the share. This is the question share. Discussed in this is the first question share discussed yesterday. This is the non-flow energy equation. This is the question non-flow energy equation. We already discussed about. Sir will ask in non-flow energy equation, steady flow energy equation, continuity equation. No, this equation is this question is based on non-flow non-flow energy equation. Okay, non-flow energy equation. We can discuss about what is non-flow energy equation. What why did they name that non-flow energy equation? Okay, we can discuss later equation. Don't worry. Uh, this non-flow energy equation is now we are this is the question based on non-flow energy equation. This non-flow energy equation derived from derived from first law of thermodynamics. Okay, first law of thermodynamics, thermodynamics, dynamics. Okay, do, if there are any spelling mistakes, there don't consider. Please avoid it. Okay, we have to discuss about a lot of things. Therefore, I move quickly. Okay, therefore now, the first question is based on non-flow energy equation. This non-flow energy equation derived from first law of thermodynamics. In our cryptic class, we have already discussed about first law of thermodynamics. What is first law of thermodynamics? We already discussed in our early cryptic classes. What is uh, uh, what is the non-flow First law of thermodynamics, which is energy can't be created or destroyed. Energy can't be created. We have already discussed in our past cookie classes. So okay, if you want to, you can please watch all the videos from beginning, from part one to uh, please from part one to current video. Energy can't be created or destroyed. This means, according to the first law of thermodynamics, we can create the energy and we can destroy the energy. That is the first law. Energy can't be created or destroyed. Okay, that's the uh, we are non we derive the equation for non-flow energy equation using first law of thermodynamics. What is the we have already discussed about this. Okay, I discussed again for exam to memorize, rememorize, to recall everything. Okay, we have already discussed about Newton energy thermo, equation of first law of thermodynamics and the equation of first law of thermodynamics. We have already discussed. Okay, okay now wait a minute. Okay, so yeah, we need a lot of page to discuss. Otherwise, okay, sorry for the time. Yeah, we already discussed that the non-flow energy equation derived from first law of thermodynamics. What is the first law of dynamics? We have already discussed that energy can't be created or destroyed. We can't create the energy and we can't destroy. We can't create the energy and we can't destroy the energy. That is the first law of thermodynamics. What is the equation of the first law of first law of thermodynamics? What is the first law equation? We have already discussed that Q is equal to delta U plus W. We have already discussed in our early group classes. Okay, Q is equal to, we have discussed very clearly about that. Q is equal to uh, Q is equal to delta U plus delta W. Q is equal to delta U plus delta W. Okay, we have discussed about how to memorize this equation. We already discussed in early. A, B, C, D, E, F, G. If you say from A to Z in alphabetic order, Q, A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W. That is, it will be in alphabetic order. Q is equal to delta U plus W. Q is equal to delta U plus W. What is Q? We have discussed. Choose energy, input energy or output energy. If we there is a system, for example, there is a container, there is a small container, small bucket, okay, small container, small container. If we sometimes we will give energy to the system, or the energy will be released from the container or system. System we already discussed in advanced level, but it's system, okay. That is just a container. Now, this the energy, input energy or output energy. U. U means what is U? U is the capital U. Capital U is internal energy. Internal energy. Here we discuss about gas. There is gas inside of this container. We discuss U means is the internal energy of the gas. Okay, U. What is W? W is work done. Work done. We already discussed. Just memorize everything, recall everything. Okay. Then they discussed. Okay, in first question, they discussed another things that uh, please assume that this is a system, just a container. Uh, if we give energy, if we give energy to the system, Q plus, okay. For example, we give 10 kilojoule to the system, it's container system, correct weight system. If we give the assume that the volume of the container system is a V, if we give the energy to the system, Q plus. If energy is if the energy is released from the if the energy is released from the system, that is minus Q. If we give energy to the system, that is Q, that is, will be Q plus. We don't confuse when we do the questions. We will understand what is the meaning of this. Okay. If if energy comes to the system, Q will be plus value. If energy released from the system, Q will be minus value. Minus value. Q here Q plus value. Q greater than zero. Here Q less than zero. Okay. Then uh, uh, here this the system. We discussed about Q plus and Q minus. Then said that this is a system. This is a system. No, this is a system. If the system do any work, if the system do any work, W will be plus, work done will be plus. Or otherwise, if the system did if the system did any work, W will be plus. Otherwise, W will be minus. For example, uh, the system uh, uh, the system do a work, for example, 10 kilojoule. Therefore, the work W will be W is equal to plus 10 kilojoule because the system did the work. For example, we do people or anything, we did work. System didn't do any work. We did any work. For example, we move the system. Okay, this is a big container. We just move from one place to another place using applying energy. Okay, applying energy. If we if, by giving force, we can move. We have to give energy. If we give energy to this if we do any work, if we already discussed in advanced level, there is this is the container, we apply a force to move this system. Therefore we have to uh, we will we have to apply force, sufficient force to move. That time we did energy work, okay, work energy is we have to we are doing work. W is equal to, already discussed this in, W is equal to F into D. W is equal to F into D. If if the system do the work, the W will be placed. We will discuss about if we do the work, for example, we people or anything do the work, that is W will be minus 10 kilojoule. That is the example. I move this system from this place to this place you by applying energy. Therefore, for example, I spent 10 20 joule to move the system. Therefore, work done is equal to minus 20 joule because the system didn't do any work. We did the work. Therefore, minus. Okay. So discuss about this. Okay. Then say therefore, for summary, if energy comes to the system, Q plus. If the energy released from the system, Q minus. If the system do any work, if the system do any work, W plus. If uh, if if the system didn't do any work, but if we do the work, other external factors do the work, it will be W minus because W plus if system do anything. If another factors do anything, that will be W minus. Okay. Now we have to discuss about U. What is U? U is internal energy. Internal energy. U is internal energy. We already know delta U is change in U is internal energy. Delta U is change in change in the internal energy, change in the internal internal energy, internal energy. Okay, internal energy, the internal energy delta U change in internal energy. Delta U is equal to, I just recall the advanced level. Okay, this is not our thermodynamics. This is very easy, basic of advanced level. Delta U is equal to U2 minus U1, because U2 minus U1. Why U2 minus U1? It's the final stage. Final. This is the final internal energy of the system. This U1 is initial initial internal energy of the system. Therefore, if you want to find the change in internal energy, you have to uh, subtract from last to initial. That is from final initial last stage, final stage to initial stage. W is equal to U2 minus U1. U1 initial stage, U2 final stage. Then share discuss that. Uh, for example, this is the system. There is a gas inside, or any flow. Any For example, there is a gas inside of this system. Okay, the energy of the internal energy of the system is now U1. Okay, then they say that is very simple. Now the energy is, for example, U1. Now the energy, the internal energy of the system change to U2, from U1 to now initially U1, now U2. Okay. Delta, now as we discussed earlier, U delta U is equal to U1 minus U2. Okay. If, for example, U1 is greater than U2. Okay. If the U1 is greater than U2, what will be delta U is equal to U2 minus U1. If the U1, the initial internal energy of the of the system is greater than final final internal energy. Therefore, if we subtract from final to initial, U2 minus U1, we will get minus value, because U2 is small, U2 is small, U1 is big. U2 is less than U1. Therefore, we will get minus value. Okay. Then in the system, U initial initially U1 internal energy of the system is U1. The final the final internal energy of the system is U2. Now U2 is greater than U1. Therefore, delta U will be always the equation will not be changed. Okay, always the equation of the delta U, change in the internal energy, always delta U is equal to U2. uh, Mostly don't use small u. Okay, delta U is equal to in our questions we will use small u. The in uh, there we will discuss did we use small, why do we use small u here. In commonly use capital U. Delta U is equal to U1 U2 minus U1. I was said that it's very easy, uh, very simple. No, we move. If you this is the final internal energy. Final. This is the phase energy, internal energy. Therefore, if the final energy is less than internal phase initial internal energy, the final delta will be minus. If the final now uh, final, if the internal energy is higher than uh, initial internal energy, the delta will be plus. Sir, discuss about. Okay, therefore, sir, say that we have to say, recall the delta u delta u may be plus or delta u may minus or delta u may be zero. If the in initial state, if it's assumed that in initial state the internal energy is u. Now also at final stage also the internal energy of the system is u. Therefore, what is delta u? Zero. There was a this recall them. Okay. Then uh, that's the thing. If the internal of the there is a system, if there is now there is internal energy u days. Okay. If the internal energy increases, if the internal energy increases, uh, if the internal energy increases, delta u will be plus because why the final stage of the final internal energy will be higher than initial value. Therefore, delta u will be plus. If the internal energy of the system decrease, uh, delta u will become minus. We have discussed final in earlier the internal energy was higher. Now the internal energy was low. Therefore, the change will be minus because final to we subtract from final stage to from final we subtract from final stage to initial stage. Therefore, minus is very simple. Now, therefore, we don't to discuss very deeply. Uh, then then said one that we must we must be very careful to apply the non-flow energy equation to the system. Say that now we are discussing about the non-flow energy equation. No, say that we must use the equations here in non-flow energy equation. We what is the equation? Q is equal to delta U plus W. Q is equal to Q Lm of Q is okay. Q is equal to delta U plus W. Say that we don't need to memorize the theory. Okay, we don't need to memorize what is mostly we don't need to memorize about what is thermodynamics, what is the first law of thermodynamics, what is the second law of thermodynamics. We don't need, but we must have to apply the theory to the question. Okay, for example, in steady flow in uh, sorry, but in non-flow equation, now we are discussing about non-flow equation. In non-flow equation, non-flow energy equation, non equation, we derive this equation uh, from first law of thermodynamics. We derive this equation. Equation is used for non-flow energy equation. They also say that we must use this equation very carefully. Don't Q is delta U plus W. Say that don't confuse with the equation. Don't interchange like that. Delta U is equal to Q plus the if you write this is wrong. No. Say that we must use the theory and the equation very carefully. This is the correct equation. Exactly correct equation. Okay. So say that we don't need to derive the non-flow energy equation. Uh, in exam, they will not ask about. Please, we now we now derive the non-flow equation, non-flow energy equation for that Q is equal to delta U plus W. No, say that they will not ask. Please derive this in advanced level time. We derive the equation then from theories, but they say that there is no time to derive these equations. But we have to apply. Therefore, they will ask that how did we get this Q is equal to delta U plus W. Just we have to apply this equation. It's enough. Okay, that's say that we have to use this equation, all the equation very carefully. Okay, this all the things. So discussion first question. This is the first question. Uh, in next video, I think this was the first question of Sher's video. Okay, uh, Sher explained uh, discuss what we have discussed till now. We have discussed a lot of things now known. We discussed some things, some theories and equations now no. So say that it says explain about the theories. We were doing this question number one. Okay, in this next video, we can discuss about this question, how to answer. It's a very simple question. This is a question from non-flow energy equation. Okay, the video is going very long. Therefore, in next video we can discuss about that. Okay, bye.